Hi, class 8, and this is another chapter of physics, which is called force and pressure. The water, as you see, is coming with a force, right? So, force means something which is a push or a pull. Anything that is push and pull is known as force. And what can force do? Force can change the size of any object or change the shape of the body. In physics, what do we define force as? Force is actually measured in a unit which is called Newton. And how do we define 1 Newton of force? So this is the definition of 1 Newton of force. So we should know that force is equal to mass into acceleration. Acceleration, you won't know the meaning of it now. It means how much its speed is happening 1 meter in 1 second. So unit of force is when 1 kg of mass is increasing its speed 1 meter in 1 second. That is known as 1 Newton of force. Okay. Unit of force is when 1 kg of now a force creates something which is known as a turn. Okay, like if I'm turning this phone, if I'm turning this phone, how much is the turn? If I have a fixed axis out here, and if I give a push here, so due to the fixed axis, I'm seeing that whenever there is a push, it is turning, right? It is turning. So this is known as the turning effect of force. Turning effect of force is also known as moment of force. Moment of force will also be known as torque. So turning effect of force is also called moment of force, is also called torque. These are the things that you should know. So what is a turning effect of force? Means what are the factors which make the turn effect of a force? The factors which is so moment of force means how much turn is happening is equal to force into distance. That is the magnitude of the force which is in Newton and distance, perpendicular distance from the force to the pivot point. So this is meter. So moment of force unit is equal to Newton meter. Okay. This I'll explain a little bit. Perpendicular distance of the force from the pivot point. This is the pivot point. This is the pivot point. Pivot means when the thing is moving. Perpendicular force means the line. This is the line of action of the force, and this is the line of action of the force, and the perpendicular distance. This is this what affects the turning effect. If the distance is more, the turn will be more. If the distance is less, you can see that the turn is less. That's what is momentum force. Some very good examples of moment of force, which is called torque, is we have a range, right? We have a screwdriver or a range at home, and due to which we see that. So, what is moment of force? First, we know practical life is physics. Physics is nothing else. Force into distance. If I make the distance more, obviously the turn will be more, and hence they have a long hand. Why do they have a long hand? So that with a small amount of force, just by increasing the distance, you're getting a big turn and it can tighten a screw very properly. Okay, what is the unit of moment of force? The SI unit of moment of force is Newton meter. We said this is the SI, which is a standard unit, right? Standard family member. We always have a brother. What is a younger brother? CGS unit. So Newton's younger brother is dyne and meter's younger brother is centimeter. Hence, the moment of force for CGS unit is dyne centimeter. Now, always the younger and the elder brother has a relationship between them. So, what is a relationship between them? 1 Newton meter. So, 1 Newton is equal to 10 to the power 5 dyne, which we should know. And 1 meter means 100 centimeter. So, therefore, 1 Newton meter is equal to 10 to the power 7 dyne centimeter. So, we should know that what is the relationship between SI and CGS is 1 Newton meter is equal to 10 to the power 7 dyne centimeter. Okay. Now, if you take a scale, let's say we have a scale and this is a pivot. Now, if I put a board out here, what do we see? We see that it is turning this way, right? It is turning this way. You can do it at home also. It's not very difficult. This only we will see in terms of this graphic representation. So, this is the axis of rotation. and if I put it on my right, this is axis of rotation. If I put it on the right, we'll see that it is going this way. It is going this way. What is it? Now clockwise. So we can say that when we have a scale and a force is given on the right hand side, it goes this way. What is this way? This is known as one type of rotation. We'll talk about that later. And this will go this way. What is this? The another type of rotation. So we can say that when a body, this is one is clockwise and the other is anti-clockwise. Clockwise is usually taken as a negative value and anti-clockwise is taken as a positive value. So let us understand how is it going. It is going this way. Okay, so clock में what is a clock? A clock is like this, which is 12, 1, 2, 3, 4, 5, 6. It is going this way, means it is going this way, right? So it is that anti-clockwise rotation, and this one is going this way, which is this way. So whenever a body is going in a clockwise rotation, it is known as a clockwise moment. Clockwise moment is always taken as positive and anti-clockwise is taken as negative. Some riddles like why is the handle of a screwdriver made so long? So everything is physics, life is physics only, all modern day life is physics. So moment of force means the turn. You need to turn a screwdriver, right? You need to turn and screw it. So moment of force is force into displacement. If it is force into distance, if the distance is more, the turn will be more. Hence the handle of a screwdriver is made long. What make a carpenter put handles at the end of the door? This is the door and this is the axis of rotation, means this is a pivot, right? This is the perpendicular distance and the door handle is here. That means you are pushing it. That means the force is applied at here. More the distance it is from the pivot point, more will be the turn. So with a less amount of force, you can have a more turn. If the carpenter is not knowledgeable, he will put the handle here, and when the handle is here, your distance will increase, your turning will decrease, and for that you need to give more force. You can also check it up in your home. If you push the door this way, it will open easily. If you push the door here, it will take a lot of force. Okay, we will now do pressure. Before we do pressure, you have to know what is a 90-degree force. A 90-degree force is called as a thrust. So any 90-degree force on a surface is known as thrust. So thrust is a special 90-degree force. How much thrust do you require on a single surface area? That is known as pressure. So pressure, what is the formula of pressure, is equal to, is defined as the force applied per unit area. The word unit means one. So it is 1 meter square or in 1 centimeter square. Always square is for area and cube is for volume. Remember it. So in 1 meter square of area, how much of thrust is required? That is known as thrust is applying, that is known as pressure. So pressure is equal to force. It happens in Newton and area happens in meter square. So pressure is Newton by meter square, right? So Newton by meter square is known as Pascal. So pressure unit is Pascal. Okay. We have known that pressure is equal to thrust by area. So these are reciprocal. What is the meaning of the word reciprocal? Reciprocal means opposite to each other. He increases, so he decreases. So we can see that if the thrust is remaining the same, if I increase the area out here, if I increase the area, the thrust gets distributed over the whole of the area. Okay, thrust is getting distributed over the whole of the area. So more area means less pressure. On the contrary, if I decrease the area, then pressure will be more. That means the thrust is only in this area, so the pressure is more. Okay. The examples of these are daily examples. Everything is physics. I kept on telling you, so you can just have a proof point of that. Now, railway lines. Why do the railway lines have these tracks? Why are the railway tracks having this kind of a feature, which is known as sleeper? These are wooden sleepers. Now the train is going on these tracks only, right? The area of the train usually is equal to area on which the train is going is less. So the pressure will be very high on these railway lines. So what we have done is we have increased the pressure with the help of these sleepers. Okay, I'll rub this. So in when the train is here, it is increasing in this much area. It is increasing this much area. So what is happening is we have deliberately increased the area so that the pressure on the railway tracks is less. Another example that you need to know is the building. The buildings have got, let's say, this is the actual building. The building will give a lot of thrust on these area. So if I increase the area, then the pressure on the ground will be much low. Hence, you have a building which has got a huge foundation. Why the foundation is such large is we are increasing the area so that the pressure is distributed with so much of area, and okay, the thrust is on so much of area, and the pressure is less. Why do we have pains while we wear heels? Again, pressure is equal to thrust by area. So the area, you're seeing that this lady has got such less area to put her entire thrust in. Okay, the thrust is acting on so much of less area. Hence, the pressure on her heels is much more, and hence she will have pains on her knees, okay, and calf muscles also. Now let us come to a topic which is known as liquid pressure. The earlier topic called pressure is equal to thrust by area is applicable for solids. For liquids, we have a different method of calculating pressure. Liquid also gives a lot of pressure, right? If you put your hand in, you see that so much of pressure they give. What is the liquid pressure dependent on? We can take an example that we have taken a balloon out here, okay, and we have taken some water, okay, some water is here. The balloon is applied with a certain pressure by the liquid, and this is known as the liquid column. That is, this is the height of the liquid. When I increase the water height, which is the liquid column, you'll see that more inflated happens. That means I can say more pressure has happened here due to more height of liquid column. Okay, so that means liquid pressure depends upon height. Another example is we have made we have had a jar out here where there is a hole called A, called B, and called C. This is the height of the liquid column only for A, so the pressure is less. This is for B, so the pressure is a little more. This is for C, pressure is high. So we can say that more height means more pressure. You know? So pressure, okay, depends upon height of the liquid column. Okay, and it also depends upon the density of the liquid. If I substitute it with another liquid which has got very high density, we'll see that it will go farther away. Okay, and it depends upon acceleration due to gravity, which is a constant. So liquid pressure depends upon height of the liquid column and the density of the liquid. Hence, pressure of the liquid is equal to h rho g. The rho is called the density. So height of the liquid column, density of the liquid into g. That is how you measure the liquid pressure. Okay. Now there is another thing which is known as liquid. Why does a liquid seek its own level, and what is it? It means that we have different types of A. This is B type, this is C type, this is D type, and this is E type. Different types and different shapes of columns. Okay. And if we pour a liquid out here and they are interconnected with each other, we'll see that they have the same height. So we say that liquid seeks its own level. Okay. That is how liquid seeks its own level. There are some consequences of laws of liquid pressure, which we will tell you in the next slide. You should so pressure, okay, depends upon height of the liquid column. Okay, and it also depends upon the density of the liquid. If I substitute it with another liquid which has got very high density, we'll see that it will go farther away. Okay, and it depends upon acceleration due to gravity, which is a constant. So liquid pressure depends upon height of the liquid column and the density of the liquid. Hence, pressure of the liquid is equal to h rho g. The rho is called the density. So height of the liquid column, density of the liquid into g. That is how you measure the liquid pressure. Okay. Now, all physics is practical application bound. Okay, so what is the application of the liquid pressure that you about in the previous slide? Is the dam wall is like this. So this is the dam wall. It is always a slanting way. It always comes broader, broader, broader. Why does it happen? See, at point A, What is the liquid column? This is the liquid column. So we know that pressure in a liquid is equal to H rho G. Rho is same, it is a density of water only. So G is constant. So both these are constants, we leave them out. So this is a relationship between pressure and height of the liquid column, right? Now this is A is height is less, pressure is less. Okay, now let's come to B. Height of the liquid column is increasing. So pressure of the water here will be more. Hence we have to make it look broader. Pressure out here is height is much more. The liquid column will give more pressure out here. So I need to make it much more broader. So this is the practical application of laws of liquid pressure. Okay. Earth is round and it has got layers of air around it, layers of air. This is the first layer, this is the second layer, this is the third layer, this is the fourth layer. So when you go to a mountain, okay, you are subjected to only this much layer of air. So atmospheric pressure is less when you're at the mountains. Okay, clear? Once a person is here, that is at the ground level, this is known as the sea level. Okay, he is subjected to this layer and this layer and this layer and this layer. Many layers are affecting him. So we say that atmospheric pressure is more at the ground level, which is known as the sea level. Okay, now every object in this earth, we are standing here. Okay, we are not hanging in the air. So every object that is here is, this one is here, so it is subjected to atmospheric pressure, and that is what why it is shown like this. So atmospheric pressure is shown here. So the pressure is on the liquid, pressure is on the liquid, pressure is on the liquid, pressure is on the liquid. Why do the syringes take liquid? How do they take it? When you take a syringe, you see that we are pulling it, right? While we are pulling it, let's say this is the syringe, we are pulling it. So what we are doing, we are taking away the air. When we are taking away the air, there is no air. So that means there is no pressure, less pressure, we'll not say low pressure. So here there is low pressure. No pressure means we'll call it as a low pressure. So there is a low pressure here. Where there is a low pressure, there is a low pressure here. Pressure always goes from high to low. Remember it. Pressure always has the tendency to go towards low from high. So it always goes from high to low. So he will go from high. This is a low pressure region, right? So he will go from high to low, and that's how he will take in the liquid. And that's how syringes are taken in the liquid with injections, or any kind of a syringe works in the same way. The same way you also drink water in a straw. This syringe is can be substituted with straw. So once you have the straw, you are sucking the air, right? When you're sucking the air, that means the straw has got a low pressure and the liquid is subjected to atmospheric pressure. The liquid is coming inside your straw. Why this is done? So I told you that the effect of atmospheric pressure on humans in high altitude, we already said in the last slide that air is having different layers, okay, and when you're in the mountain, you have less air. So atmospheric pressure is very less in the mountain. Let's say you're in the mountain, atmospheric pressure is less. Pressure always has a tendency to go from high to low. So what is high? What is high? Your blood pressure is high. So blood will flow from high and come towards low region. Hence, the blood is coming out of the nose and thus to equalize the pressure. Now we have the calculation. We'll do the numericals now. And so I told you that the effect of atmospheric pressure on humans in high altitude, we already said in the last slide that air is having different layers, okay, and when you're in the mountain, you have less air. So atmospheric pressure is very less in the mountain. Let's say you're in the mountain, atmospheric pressure is less. Pressure always has a tendency to go from high to low. So what is numericals? You have to know very important things. One is don't break pairs. This I've told in the earlier videos also. Pairs. That is, Newton is SI unit. It should always pair with meter. If it is centimeter, you have to bring it back to meter. Okay, so let's understand this thing. Force of 5 Newton is applying at a distance of 20 centimeter. Newton and meter will go hand in hand. Here there is centimeter, it will not go. This pair won't match. So we have to get the pairs done. So what is given? Given is force is equal to 5 Newton. Okay, distance. What is the distance? Distance is equal to 20 centimeter. Centimeter is nobody's unit. Usually distance in class 8, it is written as D, but in the higher classes, you'll see the distance is written as S. So I'm writing as S only, okay, centimeter. This has to be converted to meter, right? So this is 100. So this is 0.2 meter. So what is the moment of force? What is a moment of force? Moment of force is force into distance. So moment of force is equal to force, which is 5 Newton, into distance. I suggest you don't use decimal. Decimal is a devil. Decimal is a devil. Do not use decimal. Do as much as fractions as possible. It is 2 by 10. So it is 10 by 10, right? 10 Newton by 10 by 10, and hence this is 1 Newton meter. Okay, this is meter. So what is the answer? The answer is 1 Newton meter. The next question says that the moment of force of 10 Newton. From the unit only, you have to identify what is that. So this is Newton. The moment of force is 5 Newton meter. Okay, even if you don't understand the language, you have to understand from the SI unit that what is it talking about. It is talking about moment of force. So what is the thing that is given out here? Given is moment of force is equal to 5 Newton meter and force is equal to 10 Newton. What is a distance? Okay, they are asking you. So what is that we know? We know that moment of force is equal to force into distance. You're supposed to know this. Whatever you're supposed to know, bring the whole family of the equal to right hand equal to the left. So we write F into S is equal to MOF. So S is equal to moment of force by force. Hence distance S is equal to moment of force 5 by 10. So what is it? Distance is equal to 0.5. Distance unit is meter, so it is 0.5 meter. You should know that weight is equal to the force of Earth's gravity. So weight means force, okay? And so this is a force, okay? A solid block of weight 80 Newton and a base area. So here we are talking of a force which is 80 Newton is acting on a base area. That means this area is 1.6 meter square. That means this force is a 90-degree force. So we'll not write this, we'll call it thrust. Okay, calculate the pressure. Okay, we know that pressure is equal to thrust by area, right? Hence, pressure is equal to thrust, which is 80 Newton, divided by 1.6 meter square, your area. So Newton divided by meter square is known as Pascal. So what is the pressure? The pressure, we have to remove the decimal. Decimal is a devil. So into 10, if you give into 10 to swipe it to the right, okay, his twin brother also has to have into 10. So it is 800 divided by 16. 8 ones are 8 twos are 250s are. So the pressure is, how much is the pressure? The pressure is equal to 50 Pascal. They're asking you what is the magnitude of thrust. That is, this is the question mark. Okay, required in Newton to produce a pressure of this Pascal on an area of this centimeter square. Now Pascal is an SI unit, but centimeter square is not an SI unit. So we have to consider that to convert this centimeter square into a meter square. Okay. 1 centimeter square means 1 centimeter into 1 centimeter, which is 1 by 100 meter into 1 by 100 meter. So 1 centimeter square means 1 by 10 to the power of 4 meter square, right? So we have done this. Now let us do given. What is given? Given is pressure is equal to 26500 Pascal, right? And area is equal to 100 centimeter square. 1 centimeter square is this much meter square. So 100 centimeter square will be this into 10 to the power of 4, 1, 2, 3, 4 meter square, 1, 2, 1, 2. So area is equal to 1 by 100 meter square. Okay, this is done. Now, what is the magnitude of thrust? We know that pressure is equal to thrust by area. So thrust is equal to pressure into area. So what is thrust? Thrust is equal to pressure, which is 26500 Pascal. Okay, and area is 1 by 100. Okay, 0, 0, 0, 0. So your thrust is, what is the thrust? it is 265. Thrust is a 90-degree force, so it is 265 Newton.